Today we're going to be doing an introduction to function notation. So since inputs and outputs are so important, we have to come up with a way to write equations that highlight the input and output. Denotation C of x tells us that the cost is for a particular input or food item, C being your cost, X being your food item that you put in to get the cost out. You first need to purchase the item to get the price. So what is the cost of the hamburger? The cost of the hamburger here is $1.50. What is the cost of a shake? A cost of a shake is $1.55. Then it says, what is X when C of X equals $1.05? So now they're saying, what is the item for a cost that was $1.05? Well, we take a look at which item here was $1.05, and we have French fries. So if you were to purchase French fries, you would pay that $1.05. The next problem says, well, what is the item when you pay 70 cents? And when you pay 70 cents, you are either purchasing milk or you are purchasing coffee. So this is your Y, your output, and I'm asking you to find your input. Please pause the video and try example 2 on your own. Thank you so much for attempting example 2. So here it says the notation n of x tells us how many cells are in counting squares after x hours. So we're going to take a look at our graph. Here it says n of 10. Well, let's take a look. We know that here we have this set up as n of x, n being the number of these cells and x being the number of hours. So you want to note that on your paper. So here it's saying how many cells for 10 hours. Well, so we're going to go up to 10 and then go over. That's going to be 600 yeast cells. And you guys actually have a quiz on Friday. And in that quiz, you're going to have to explain what this is asking. So this is asking how many yeast cells in 10 hours, and then you would say that it's 600 cells. How many yeast cells in 4 hours? Well, that's an approximate. We can't get an exact here. So we're going to say that's about 100. Now, our next part says, what is x when n of x is 300? So here we're actually given a y value and asked to find the x value. So I'm going to go to 300. I'm going to go down. I would say that's about 6.2. So it's going to be 300 cells in 6.2 hours. And then 665. Well, here it looks like it's about here. We're just going to estimate. If you got a slightly different answer, that's okay. So if you got 15, I'd probably accept it. If you got 17, anywhere between 15 and 17, I would say the exact answer is about 16 hours. All right, the next problem says the notation n of b tells us that the birthday month and date for any student's name. Well, it's asking us to complete the chart. So we have a name and a birthday month. What comes first, the name or the birthday? Well, the birthday we would get from knowing the student's name. So we're going to say our input value or x value is name, while our output or y value is the student's birthday. So here we're asked for the birthday of Anna, and the birthday of Anna is June 30th. We are asked what is the input for the birthday of whose name is April 19th. We look over here and it looks like the birthday of April 19th belongs to Phil. Now here it says for B of Terrence, we get February 10th. So what is the input and what's the output? Pause the video and explain that. Really quick, write in for yourself which one is the input and which one there is the output. Very good. So the input is Terrence. We get Terrence as our name, and then what comes out is his birthday, which is February 10th. Why would we want to use student ID numbers instead of first names? Well, if you're thinking about the birthday of a specific student, you could potentially have two students with the same name and a different birthday. So let's say that Becky has a birthday on August 23rd, but then the other Becky has a birthday on April 5th, for example. So student ID numbers, well, each student only gets one ID number. And because each student has an ID number, let's say we know that the first Becky's ID number is 14718, just making up a number here. That would be August 23rd, right? Then we specifically know that this birthday belongs to that first Becky. Can there be potentially one input for a given output? More than one input for a given output? Well, yes, you could have two students with the same birthday. And that would still be a function, right? We just can't have the same input with two different outputs. Which here, if we did this one, it would be Becky's the input. And although it's a different Becky, you're still putting in the name Becky. So you want to use that student ID number. You're having a different input each time. But for the output, you could have multiple inputs and two students with the same birthday. All right, so here we're given a table. Let X be the ticket price in dollars, and P of X is then the profit. So this is asking us find the profit for this specific X value. So find the profit for a $350 ticket price. So our X value is 350 and our Y value there is 3.82. What is X when Y is 3.52? Well, X at 3.52 is 250. And another way that I like to think about this when I set it up is like P of X equals Y. So you know that X is here, and you could always replace. If the X is missing, you'll see that it's missing here. But let's say I have like P of 5. Well, that means that X is your 5 because it was put inside. So on this next problem here, like if you have h of 0.8, that is your x value. That was put inside for x here. So at 0.8, if I go over, that's about 5.2. What is x when h of x is 4? So I'm going to go to 4, and I'm going to have to extend that line all the way at 4. And here we actually have two different answers, right? So we have about 0.2 and about 0.95. Because again, a y value can have two different x values. H of 0 here, these get a little tricky, so be careful. So here I say x is 0, and then I want you to find the y value. So when x is 0, y is about 1.2. I would say it's not quite 1 because it is above 1 here. So I don't know if I would necessarily accept 1. You do want a number that's bigger than 1, so 1.1 or 1.2. What is x when h of x is 0? Well, that means that our y value is 0, and then you're plugging in your x, which is about 1.2. And again, you're comparing the time in seconds and the height of the object. So if they say h of 0.4 is 5.8, keep in mind the x represented the time in seconds, while your output was the height of the object. So here, I would want a sentence to say what this exactly means. And this means in 0.4 seconds, the object is at 5.8 feet. So very specific. In this amount of time, this is how high it will be. The chart gives the monthly average water temperature. Use function notation to say that the average temperature in March was 75. Well, again, you're going to have to take a look first which one's your X and which one's your Y. It looks like month is our X and temperatures are Y. The month will change the temperature won't change time. So here you would say the temperature T of March is 75, exactly in this format. You put March in for the temperature and you get 75 out. And you don't want to just use M, because if you did T parentheses M, well, M could also be for May. Pause the video and please do number 4 on your own. All right, thank you for completing number 4. So here it says f of 4, and then that would represent that our x here is 4, which means I'm asking you to find y. If x is 4, y is 1, 2, 3. Here, if x is negative 3, then y is negative 2. Here it says solve for x, which means I gave you the y value. And when y is 4, x is 1. What is x when f of x is negative 2? Well, we actually have two different answers here, right? It crosses negative 2 at both x's negative 1, 2 and negative 1, 2, 3. So there's two answers for that one there. So please be careful. Again, sometimes your y value can give you two different x values. All right, and these are a little bit easier. These are kind of like the ones we did the other day. What is the value of y when x is 2? Well, you would just go ahead and plug in 2. So you have negative 4 plus 7. 7 minus 4 gives us 3 here. What is the value of y for the function y equals 3x minus 15 when x equals negative 22? Well, we would have 3 times negative 22 minus 15. So negative 66 minus 15, which is negative 81. Number 3 is a little harder. What is the value for the input for the function, the quotient of the input and for less 5 when the output is negative 8? So quotient. Quotient is the answer when you divide. Input and 4, and then less by 5 when the output is negative 8. And then you can go ahead and solve that equation. We're going to skip that for right now, though. Again, I just want you to start thinking about how you're going to set these up. So quotients divided by input and 4, and then less 5 equals negative 8. Find the indicated value for the function. So here I tell you that f of x equals 4x minus 7. It looks like they put 3 in for x, so that's exactly what we're going to do here. We're going to do f of 3 equals 4 times 3 minus 7, which is 12 minus 7. So then if our input is 3, our output is 12 minus 7, which is 5. So I put 3 in, I get 5 out. I put negative 5 in, and then you are simplifying that right-hand side, negative 20 minus 7, I get negative 27 out. So that left-hand side doesn't change. It's just the right that you're simplifying. You can't do anything after that because this is specifically saying for this x value that I put in, this is what I get out. Okay, pause this video. Go ahead and complete number 2, 3, and 4 on your own. All right, so here you would put in 4 for where you have x. So negative 12 plus 10 is negative 22. You would put in negative 9 where you have x, negative 3 times negative 9 plus 10, positive 27 plus 10, so positive 37. This one's a little harder because we have some exponents here. So we have h of 6 equals 6 squared plus 5 times 6 minus 1. This should say h, so go ahead and fix that on your paper because, again, that would represent this specific equation, so it should say h. 36, 6 times 6 is 36, plus 30 minus 1. 66 minus 1, that gives us 65 there. Here we have h of negative 4. So negative 4 squared plus 5 times negative 4 minus 1. Negative 4 squared, you have to be careful here. A negative times a negative is going to give us a positive 16 there. So 16 minus 20 minus 1. 16 minus 20 is negative 4, and negative 4 minus 1 is going to give us a negative 5. So our answer here is negative 5. If negative 4 is my input, negative 5 is my output. Here we have negative 2. We put in 5, and then we have negative 2 times 5 squared minus 3 times 5 plus 8. Here you have to do the exponent before you multiply. So we have negative 2 times 25. 5 times 5 gives us 25. 3 times 5, 15. So we have negative 50 minus 15 plus 8, which is negative 65 plus 8, which gives us a negative 57 there. F of 0, we put 0 in. Let's see what we get out. So we have 0 minus 0 plus 8. That would just give us an output of 8. Sometimes you might see me give it to you in this format where I say that this is the set notation. I'm just saying that this would be the domain that I want you to put in, and then I want you to give me the range. So here, all of these are x values, and then what I would expect you to do is find the y value for each of those x values then. So you would do the same thing that we did above. You would just plug in those numbers. So you would do f of 5 equals 2 times 5 plus 7. 10 plus 7 is 17 for the first one. Then you would plug in 18. Which is 36 plus 7, which gives you 43. And then you would put in negative 5, which gives you negative 10 plus 7, which is negative 3. All right, pause this video and try 6, 7, and 8. All right, thank you so much for trying 6, 7, and 8. So here we're going to go ahead and do g of negative 2 equals 9 minus 4 times negative 2. So here we have 9. Negative 4 times negative 2 is positive 8. So our output is 17. Then I'm going to plug in 10. 9 minus 4 times 10. 9 minus 40. That's going to give us an output of negative 31. And then we have g of negative 1 equals 9 minus 4 times negative 1, which is 9 plus 4, which gives us 13. All right, let's take a look at the last two here. F of 2 equals 3 times 2 squared minus 1. 3 times 4 minus 1. 12 minus 1 gives me 11. F of 4 equals 3 times 4 squared minus 1. 3 times 16 minus 1. 48 minus 1 gives you 47. And then f of negative 3 equals 3 times negative 3 squared minus 1. Here again, you have to be careful. Negative 3 times negative 3 is a positive 9. Negative 3 times negative 3, or negative 3 squared, that double negative makes a positive. So that's 27 minus 1, which is going to give you 26. All right, and then here we have h of 1 equals 1 squared plus 8 times 1 minus 3, which is 1 plus 8 minus 3. 9 minus 3 gives us 6. H of 5 is 5 squared plus 8 times 5 minus 3. 25 plus 40 minus 3. 65 minus 3 gives us 62. H of negative 2 equals negative 2 squared plus 8 times negative 2 minus 3. So 4 minus 16 minus 3 is negative 12 minus 3, which is negative 15.